In this video, we're going to learn about the law of sines. In a much earlier video, we learned about SOHCAHTOA and how you could find sine is opposite over hypotenuse or cosines adjacent, all those things there. And we could use them to find missing angles. We could use those to find missing sides. But the thing is, SOHCAHTOA only works on a right triangle where you have one of the angles is 90 degrees. The law of sines is a much better situation because it works no matter what triangle you have. You have a right triangle, you have an acute triangle, you have an obtuse triangle. It doesn't matter. Always, law of sines is going to hold true. So you see, the thing is, we take sine of one of the angles, which we're going to call A, divide that by the side length opposite to it, so it's over here. All those are the A things. And you will get the same answer if you took sine of the angle B divided by the opposite side to that. And it's also going to be the same if you took sine of the third angle and divided by the opposite side of that. And that will give you the answer. So all three things give you the same. And you can use any two of them to try to find a missing side or a missing angle in a given triangle. Notice you could take, for example, the first two. You could say, I want to use sine A over A is sine B over B. That would be one combination of these two. And so in this case, there's two angles and two sides. That's four total quantities. If you happen to know three of those, you can use the equation to solve for the fourth. Okay, what if there's two of these things you don't know? Well, let's take a look at the next one. Let's take sine B over B equals sine C over C. So once again, there's four things in this equation. As long as you know three of them, you can use it to solve for the fourth. Okay, what if again there's two unknowns? Well, you can do the first one and the last one. And again, this is another perfectly valid equation with four variables in it. If you know three of them, plug them in, solve for the fourth. And so you get freedom to choose which any of these three equations to use. That's what this triple equation means up here. And you just use whichever one is going to help you solve the problem. And the thing is, you might say, well, what if all of them have two variables? Well, in that case, you couldn't solve the problem this way. We are going to learn another way to solve situations where that might happen. But for anything at this point in the class, one of those equations is going to have three knowns and one unknown. And you'll be able to solve it to finish out the triangle. Now, for these types of problems, we're going to have different types of them. And the first example we're going to solve is something that we call ASA type, or angle side angle. That's what ASA stands for here. Angle side angle. And let's try to draw a triangle. Notice that none of these triangles I ever draw here are going to be actually accurate in how long the sides are. It's not to scale type of thing. But we know that angle A is 25 degrees. We know angle B is 40 degrees. And we know whatever angle C is, the opposite side to that, which is over here, is 5. And this is why it's called angle side angle, is you know one of the angles, you know the side, and then you know the next angle, angle side angle. Now we're going to use this in order to solve for all the missing sides and all the missing angles for this triangle. This is called solving a triangle. If you were to set up your law of sines right now, you'd have a problem because you have one side, two angles that you know. That means there's three things you know, but those three are not going to be any one of these single equations. Every equation is only going to have two things you know and two things you don't know. You can't solve them. However, if we know two angles in a triangle, we can find the third one from just doing 180 degrees minus the other two. 180 minus 65 is 115. And then once you know the third angle now, then we can say sine of that known angle divided by the side opposite, which we also know, is equal to, let's say, sine of 40 divided by the opposite side of 40, which we'll call b. And now we have an equation with only one unknown. We can go ahead and cross multiply. B times sine of 115 degrees is 5 times sine of 40 degrees. And if we solve for b here, 5 sine of 40 divided by sine of 115. And these are all going to work out to be approximate answers on these problems because they're not going to have the nice angles. And we do want to make sure that our mode is in degrees on our calculator. Otherwise, we will get the wrong answer here. And I'm getting a b value of 3.5. That's how long that side is. Then if I want to find the other missing side, which is side A, I'll do sine of 115 over the side opposite 115 is sine of the angle 25 over the opposite side of the angle 25, which is A. I do the same kind of cross multiplying and dividing steps here. We get 5 sine of 25 degrees over sine of 115 degrees. And this will give me the following answer, 2.3. And now I have all the missing sides, all the missing angles, and I have completely solved this triangle. So this is the standard way you're going to handle an ASA type triangle.